question is, a brick is placed on a Newton meter and then on a beam balance. Here is a brick which is placed in a beam balance, and the same brick uh, is placed with the Newton meter. So now from beam balance we can see the mass is 1.5 kg plus 0.5 kg. So we can see that it would be around 2 kg. 2 kg. Then it's a Newton meter. It will tell us the weight of this brick. So its weight can be, so it is 20 Newton. 20 newtons. It's 2 kg and it's 2 Newton. So beam balance actually measure the mass of the kg is the unit of mass. Kg is the unit of mass, and Newton meter measures in newtons, which is actually the unit of weight or force. So we have two options. Newton meter will measure the weight and beam balance measures the mass. So actually this is what we have. Option C is the correct option. So which property of a body resists change from a state of rest, from change from rest, state of rest or motion? Density, mass, volume and weight. And it is actually linked with inertia, so we would consider only the mass is actually responsible for object like mass is responsible for inertia, and inertia we know that if object is in rest state it would remain at rest, if it's in state of motion it will remain in state of motion, and it is responsible for inertia like situation. Okay. Next is, the mass of a stone is found on earth using a Penn balance. Like this is the stone, and it's a Penn balance or beam balance, whatever you would call it, on earth. The weight of the stone is found using Newton meter. Here is a Newton meter and we can find out. So it is on the earth surface. Are the reading the same or different on moon? We know that from the beginning that the mass remains same. Suppose it is 2 kg on the earth surface. If you keep it with yourself on a moon, the mass remains same. The quantity of mass will not change, but on earth surface its weight will be m times g, and g is 10. Suppose mass is 2 kg, so 2 times 10 is 20 newtons. So on the earth surface uh, the weight is 20 newton, but if you move to the earth to the moon, then its value, like the value of g will change, so it would become, this is for earth, and now for moon it would be 2 times g is 1.61, I think 1.625, so you can see it would be 3.25 newtons. So mass remains same. On earth surface the mass is 2 kg, and on moon the mass is 2 kg, but due to gravitational field strength, which is g, on earth surface it is 10, like this one, and when we move to the moon it would change to 1.62. So weight varies, not mass. So we would consider as reading on pen balance, mass remains same. Actually pen balance is going to measure the mass of the stone, so it would remain same whether it is on earth surface or on moon surface. And beam balance is a Newton meter is going to measure the weight of the stone, so it would be different on both surfaces. So on earth surface it's the weight of the stone would be different, and on earth surface it would be different, but their masses would remain same. Now let's move to the fourth one. In fourth, the table shows the weight and masses of objects on different planets. On which planet is the gravitational field the largest? See, suppose mass is 20 and weight is 2. Mass is 30, weight is 4. This. Okay, so let's calculate gravitational field strength. You know that W equals m times g. So suppose weight is 2 and mass is 20 and g is, so you can divide it with 20, it would be 0.1. Here I can say it is 0.1 for the first case. Okay, now for the second it would be 4 over 30. Okay, it would be 0.13 for the second case. For the third case it would be 6 over 40. It would be, I think, 0.15. And for the last one it would be 8 over 50. It is actually 0.16. So the last one will have the largest gravitational field strength. So you can see this one is our correct option. Now in case of number 5, the mass the mass and volume of 4 different objects are shown in figure. Like suppose for A the mass is 20 and B the mass is also 20. Okay, for C mass is 10, for D mass is 10, but their volumes are different. Okay, so suppose for A, which has the smallest density, you can see mass, we know about density. Density is mass over volume. So for the first case it would be 20 over 5, which is 4. For second case it is like for C, this is case of A,